Hey everyone, in this video I'm going to show you what to do for the Eggium assignment. First thing is make sure that you are zoomed in, so a little magnifying glass and then 100% so that you can see this. So in this we are going to have different plastic eggs, and inside of them there's going to be pom-poms. So the orange/yellow pom-poms represent protons, and then the green / light blue, there's only one that has the light blue, represents neutrons. So the first one I kind of did as an example for you, but if you go down here to the letter A, and if you click on the letter A, it's going to open up the picture. So this was egg A, and then this was what was inside of it. So again, if we go back here, the orange/yellow is our protons. So if we count, we've got 1, 2, 3, 4, 5, 6, 7. Okay, so we've got 7 protons. And I put this over here for you as well. If you remember, our atomic number equals the number of protons. Okay, so our atomic number is 7 because we have 7 of the orange/yellow protons. Now the mass number is the number, our atomic number, plus the number of neutrons. So we know our atomic number is 7, and then our number of neutrons in this case, which is these green ones, is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 7 plus 8 is what gives me 15. And so my symbol then is Eg, which stands for Eggium. The mass number, which is the biggest number, goes on the top, which is 15, and then my atomic number, which is 7, goes on the bottom. Okay, now I put all of the symbols in for you already, but you have to go through, click on the letter, and then figure out your number of protons and your number of neutrons to then give you your atomic number. So, well, your mass number, which you would type in here, and then your atomic number that you would type in down at the bottom. So the text boxes are all here. You just have to click in them to get them, and then you click on the letter to find the egg. And it'll open up the picture so that you can see that. Okay? Now, the next part of these is some questions. So first off, how can we be sure that all of these are representing the Eggium? So think back to what we've talked about in terms of protons and neutrons. Which one is the one that lets you know that, hey, this is whatever element? And then if these atomic models were actual atoms, what are 2 things that are different between these atoms? So basically, what are 2 things that are different between going from one egg to the next? The definition of an isotope and what are some examples. So what did we say an isotope was? And then what are some examples? Do you think that all isotopes occur with the same frequency? Frequency just means like is something showing up over and over and over again. So are you seeing a lot of them or not a lot of them? Okay, now this one, I'm going to actually show you how to do the math on the iPad, and same thing with these. So I will make a separate video of how to do the math on this part, and same thing here. But in this video, I just wanted to show you how to open up the eggs and figure out that information. Hey everyone, in this video, I'm going to show you the rest of the Eggium about what you need to do. So I want to show you on number 3 right here. So if I have 20 animals on my farm and 12 of them are cows, then 12 out of 20 of my animals are cows. So then what you are going to be doing is figuring out the fraction for each isotope in Eggium. So for example, you know that there's 10 atoms in the sample. So 10 atoms total. Okay, and I'm only going to do one of them, but 3 of them are Eggium 15. Okay, so that means that their mass number is 15. So that would be 3 out of 10, which is 0.33. okay? And you would do that for the rest of them. So you've got 3 that you would do after that, okay? And then that is the natural abundance. So then what do you think natural abundance is? And then there's 2 ways of calculating the average mass of the isotopes. So the first one is you just go through, you add up all the masses, and then divide by the number of masses. So this is kind of like what you do typically in math whenever you find the average. So if you were trying to find your grade, right, you add up all of your numbers and then divide by how many there were. So for example, you would be adding up the masses. So you're 15 plus da-da-da-da-da, and then in the end, you're going to divide all of that by 10, okay, and then put your answer right there. Now the next one is to find the natural abundances for each one. So for that, you remember these fractions you figured out up here? You're going to take the decimal, okay, and then you are going to times it by the mass number. Okay, so for example, I would have 0.33 times 15, add it to whatever my next one is, plus my next one. So you should have 2, 3, and then 4, and then put your answer right there, okay? And then 5 and 6 are your own questions. And then right here, I want to show you this one. So for this, if you notice, we took this percentage and we made it into a decimal form. And all you have to do that is move the decimal 2 places to the left. So for example here, 1, 2, this would be 0.20, and then you're going to times that by the mass number. So by 10, and then 0.80 times 11, okay? And whenever you go through and you do that, you should end up with, or you should be able to get the approximate weighted average, which is going to be 10.80. And then you will need your periodic table. So if you look on your periodic table for boron, its actual atomic mass on the periodic table is 10.81, okay? And so then you're doing that for all of these, okay? Again, if you have any questions about this or if you need help, then please let me know.